In this video, we're going to pick up where we left off in the last video, where we're calculating the total distance something is from a point of origin and how it got there. In the last video, we came to understand that the total distance something is from a point of reference, that total distance, d sub f, is found by knowing how far it was from that original point plus how far it moves. And a lot of times we said that initial distance is 0, so that simplifies a lot of the problems. So what we need to do now is come to understand how to find that change in position, that change in distance, and that is the delta d. So that's what we're going to do. Let's get going with that right now. So now we're gonna go back to this equation. We're going to go back to this equation, the delta d, and we're going to look at how that factors in. Because we already said that we can find the change in position using VT. So that equation now becomes how far something is from someplace else if it's moving. So here's the logic. How far am I from McDonald's if I'm moving at a rate of 2 yards per second? So if I'm 300 yards to start with, and I moved for 10 seconds, I've moved another 20 yards, so now I'm 320 yards away. So my final distance is, where did I start, and then how much did I move? And how much did I move is answered by the question, distance, velocity times time. Distance equals velocity times time. So putting it all together, I can say that my final position, the distance I am from that relative place, the final distance is how far was I to start with plus how far did I move. But instead of writing it as delta d, I'm going to write the velocity equation in here. So my final distance is my initial distance plus how fast am I moving and how long did I move. Now, in many cases, the initial distance is going to be 0. It hasn't moved. We're measuring it from the starting line, and we're measuring until it gets to the ending line. So for a sprinter doing the 100-yard dash, initial distance is 0, so there's no displacement. It is at the starting line, and then the final distance is 100, and we want to know how fast they were going. So 10 seconds later, they're going 10 meters per second. We can do those when the initial distance is 0. It's very simple. So let's do a couple of problems just to get things going. So we're going to keep this equation down as our relevant equation for finding the distance given an initial distance plus the change in position, VT. So we'll do a jogger, and we're going to start the jogger off at some distance from a bridge, and they're going away from the bridge. So we're going to say that initially the jogger is 2 miles from the bridge. And we're going to say the question is, how far is the jogger from the bridge 2 hours later? So we're going to say 2 hours later. So we're going to say the time is 2 hours. And now we need to know how fast the jogger is jogging. What is the jogger's velocity? And I'm going to say that the jogger is doing 10-minute miles, so that means he's doing 6 miles per hour. Miles per hour. So this becomes our given. This becomes our given information. The initial distance is 2 miles. The time is 2 hours. And the velocity is 6 miles per hour. So here's our relevant equation. This is the equation that connects distance, velocity, and time to the final distance. So I'm going to rewrite that equation, and then we're going to, following our method for solving problems, find the relevant equation, find what's given, plug it in, and then do the math. So the relevant equation is the final distance is equal to the initial distance from the bridge plus velocity times time. So I'm going to say this is 2. Okay? I'm not going to say it's 2. It is 2. It was given. D sub F equals 2 miles plus, I'm going to say that velocity is 6 and I'm multiplying that by the time, 2 hours. Okay? So if I multiply my units, I'm going to have mile hours over hours. So the hours are going to cancel, and that's going to give me miles, which is what we want. So I'm going to the next calculation, the next line of the math. D sub F equals 2 miles plus, and again, I'm going to illustrate the canceling. So the hours, so this is hours over 1. Hours are going to cancel, and it's going to give me just the miles. And then 6 times 2 is 12. So now I have the final distance. The final distance is 2 miles plus 12 miles. Miles adds to miles, and that's very convenient. And that gives us an answer of D sub F equals 14 miles. Keeping up with the units is very important, but for a lot of beginning physics students, using what I call the blind faith method is a little easier. And that's where we just, and this is bad science, it's bad math, but it simplifies the arithmetic because it's a little less distracting. And that is where we look at the formula to start with. We look at the formula in the general case, and we plug in what the units are in our mind, and then we cancel them out, and we say, okay, if I have miles per hour and hours, they're going to cancel out and give me miles, so I'll have miles, 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 and I can use the blind faith method and just put the numbers in. So we'll do another problem, and this is probably more typical. A race car crosses the starting line at 100 miles per hour, so V equals 100 miles per hour. And how far is it after a half an hour? So T equals 0.5 hours. So how far is it from the starting line? Well, that means that the initial distance was 0 because we're measuring from the starting line and everything is relative to the starting line. So when it crossed the starting line and they started the stopwatch, the distance was 0. So we can ignore the DI. So we're going to rewrite the equation, the relevant equation. D sub F equals DI plus VT. Now DI is 0. So 0 plus anything is anything. So dF equals VT. It's going to be very simple now. We're going to take the 100. I'm not even going to use the colors on this. I'm going to plug my numbers in. The final distance equals 100 times 0.5. 100 times 0.5 is 50. And because we're using blind faith, we know the unit's canceled, and that's going to give us miles. And that's the simple case where initial distance is 0. This is so easy that there's really no point in doing another example. The more general case where we start with some distance from something and it moves requires us to use the whole equation. that's all there is to doing this. So it boils down to how far is it from something is equal to how far was it from something to start with plus how far did it move. So the change in distance is velocity times time. Change in distance is velocity times time. The total distance away from whatever it is that you're considering is how far was it to start with plus how far did it move. And how far did it move is velocity times time. This is a very fundamental piece of the physics, and once you master this, it really the next step is if the velocity is changing, it's just one more term. But mastering this part of the equation right here, and understanding that a lot of times d sub I is 0, this is the first step in motion physics, and it really comes back down to the final place is where did it start plus how far did it move, and how do we know how far it moved? We calculate that with v times t. I can say this 100 different ways and I end up basically the same thing. The final distance is the initial distance plus velocity times time. The final distance is how far was it to start with plus how far did it move. How far did it move is vt. I can just go through this over and over again, and it's the same outcome. That's good because that's what we want from our science. We want to get the outcome to be the same every time. So, in the next video, we will look at what happens when velocity is changing. But that's it for this case. The math is simple. Write down what's given. Write down the relevant equation. Plug the numbers in and solve. Thanks for watching, and hope you enjoyed the video. And we'll see you in the next one.